Welcome to the Let's Talk About series, where we focus on game concepts in Unreal Engine 5 and in particular the Lyra starter project. In this episode, we're going to talk a little bit about the startup process, highlighting kind of the path that the engine goes when you either hit play in the editor or launch a game. And so we'll walk through that various content with a hope to get a better understanding of how you get from initiation through being in a match, so you can ingest your own logic where necessary. So first, we're going to look at two basic elements of Unreal Engine. The first being project settings and the second being world settings. So you can get to project settings under the Edit menu bar, pull up project settings, and in particular we're looking at the maps and modes section of project settings. And the world settings are tied to the level map that you have open, and in this case we have the Lyra front end map open, and so we're looking at the world settings specific for the Lyra world. So the first thing to note is that whenever you launch a game, the very first class that gets initiated and set up is the game instance. So at the bottom of my screen, you see that the project settings define which game instance the application will launch, and that sort of starts the journey. There are other things that launch and start up, but for our purposes, game instance is the first thing that initiates, and the default map is pulled out of the project settings, and that's the first map that the application will load. So in our case, the Lyra game instance gets loaded, the Lyra front end map gets loaded, and then control sort of bounces over to the world settings for that map. Now the map may have a game mode set up, which would say for this particular map, these are my pawns, HUDs, controller class, game state, player state, etc. As you see here, they're blank, which means by default, control is passed back to project settings, and the default project settings are used. So in this case, the default game mode will be picked up, the Lyra game mode will be picked up, the default pawn will be the Lyra character, the HUD, the player controller, the game state, the player state, etc. So in this setup, which is all standard Unreal, the 1 game instance, 2 the map, 3 the game mode, world settings, and 4 the defaults if there are no world settings, those are all standard. The only thing that Lyra injects into this is the gameplay experience, which can override some of those previously set values and ingest other logic into the startup cycle. So in this case, you see that the Lyra front end map has a gameplay experience, Lyra front end experience. And so that will inject new logic into the startup process. If we take a look at that. So if we open up the Lyra front end experience, the first thing we note is that it doesn't override the pawn. So the default pawn data is blank, which is why you don't see a character in the menu screen. In the actions array, the first thing it does is it disables split screen. And in looking through a bunch of the code, there is some sort of half-written split screen logic that would indicate that with Epic Online Services version 2, there looks to be more support for split screen. But as of now, Lyra uses version 1 of Epic Online Services, which seems to have some issues with split screen, so they go ahead and disable it upon startup. As you scroll down, you see that we add or ingest 2 components. The first one being the most important one, which is the game state gets a front end state component added to it. and it's only added on the client, which makes sense since we're in the main menu. We're not actually in a match, so there'd be no point in adding it on the server. And then it adds the music manager component. And then there's some other things it's doing about adding the front end slot and the widget and all those other things. But the most important aspect here is that the front end state component gets added to the Lyra game state. And if you take a look at under the covers, what is that actually doing? In the blueprint, it exposes the main screen class and the press start class. So the press start class is only used if you're on a console, where you typically press start to initiate. If you're on a PC, you typically don't have a start screen. You typically go right to the main menu upon load. So those two classes are defined in that component. And you'll see in the try-show main logic here that I've just clipped into the screen is that the push widget to layer will be triggered. That will trigger to this UI layer menu tag, and it will push the main screen class. So this is how the Lyra front end widget ends up on your screen inside the Lyra front end map. So the experience adds the component to the game state. The component then initializes. It looks to this variable, it picks that variable up, and it pushes the menu onto your screen. And at that point, we are sort of up and running with our main menu presented to our players. Now, if you expand the outliner, if you're in editor and you expand the outliner, you'll see that the game mode was initiated from the default settings. You'll see the Lyra character was spun up. The game state was spun up. It has the component on it that we just talked about. The player controller was spun up and the player state was spun up. Any of these yellow actors are actors that were added through code of the startup process, not the actual level construct. So white actors are loaded from the map and instantiated into the world. Yellow actors are loaded via various elements of the code. And so you end up with a world, a populated world where you have a player controller, you actually have a player state, and you're just looking at a widget on top of an empty world game. Now, game instance doesn't appear in the list, the outliner list, because it's not an actor. It derives from U object and not a actor. And the important distinction is that A actors can be spawned into a world. U objects are still instantiated, but they don't show up in the world. And the important thing to note is that the game instance, not only is it the first class to initialize, it's the only class that persists through moving from map to map. We'll talk a little bit more about that later, but if you think about this particular map that we're in, which is the front end map, the game instance is not associated with that map. It's associated with your computer, basically. So your copy of the application up and running on your computer, if you run two copies, you'll end up with two game instances. But let's just assume you've got one copy up and running. And in that case, you're going to have one U object called game instance, and then a variety of actors that are going to be loaded into that level based on the startup logic that we discussed. So from this point, you're up and running basically in a level. You've got a main menu, and you'll make your various selections in that main menu. All right, so you'll either do a quick play or a starting of a new game, browse for an existing game. An example where you're going to host a game, and I didn't go through all of the widgets and all of the sub widgets, but basically as you click through the buttons on the screen, if you're hosting a game, you end up at the bottom here where you're going to end up calling the host session from the common session subsystem. So the subsystem, common session subsystem, is what manages the various copies of the game that are running in sort of a server mode. We'll talk a little bit about the difference between a server and a session, but basically you're initiating that I want to host a session. And so you're basically broadcasting that you're about to launch up a server for people to come join. On the other side of that equation, if you browse for games, you're actually interacting with the session subsystem as well, but you're searching for host games that you might join. And then when you click the game you want to join, you trigger the join session from the common session subsystem. So in both of those cases, we're using the common session subsystem, one to host a game and one to join a game. And then let's just follow the host path for a second, you then will see the loading screen pop up, and you will actually be transferred into the next map. And so once the loading is complete, you're going to be popped up into your game or into your match. Now, what's important in that is this notion of seamless versus non-seamless travel. When you left the Lyra menu and you appeared in the game instance on the server, your player controller was destroyed, your player state was destroyed, all of your actors were basically destroyed, and then you created new actors when you launched into the match. So there's nothing you can carry forward from the menu map to the game match. So even though the classes are the same, so the game state and the player controller and the player state, those classes are the same classes. They're new copies of those classes. So nothing persists from one to another. And if you had a map that led to another map, supposedly you had a portal in this map and it took you to another map, unless you were, you're responsible for managing any of the information that has to go along to the new map and reconstruct it on the new map. So we'll talk a little bit about that, but it's important to know that when you end a match and you go back to the menu, or when you leave the menu and you go into a match, even though the class names are the same, they're brand new instances of it. And so they're all reset back to their default state when you launch into that. So I talked quickly about seamless and non-seamless, and this is just a copy out of the documentation. This one happens to be the 427, but it's the same for 5.0 and 5.1, and probably for the foreseeable future. So Unreal supports both seamless and non-seamless travel. Now, despite the fact that the documentation says use seamless travel when possible, there are very few cases when it's possible. It's intended to give you a different experience. You can read the note there. But if you look at the number of cases where non-seamless travel has to occur, that's going to be the majority of our traveling scenarios. So non-seamless travel, if we're loading a map for the first time, well, that's what we did when we hosted a match, right? We loaded into a different map. We left the menu map and we entered into the match map. When you're connecting to a server for the first time as a client, well, that's when you click join. So when you click join, you move from the menu into an already existing server. So you have to travel non-seamlessly in that scenario. And then when you want to end a match and start a new match, so the victory moment where you're resetting a match is also a non-seamless travel. So in the vast majority of cases, you're going to be traveling in a non-seamless way in Unreal. It's just the way structure is built, which means that outside of the game instance, you have to plan for the fact that everything is going to be blown away and rebuilt each time you travel. So let's take a little bit deeper dive into what happens through the Lyra code as you hit those two nodes that I just talked about a few minutes ago, keeping an eye out for this UWorld server travel, which what will happen when we host a session, and the player controller client travel, which is when you will join an existing map up and running up on a server. So let's take the host path. And when you see the common session subsystem host session, you can see the C++ logic that host session in the common session subsystem is what's called when we call this node. So host session, target common session subsystem, session subsystem, host session, we get past the player controller, and we get past a host session request. So that's these two parameters that we pass in here. They show up here. As the code executes, it's doing a couple of checks to make sure you didn't forget to connect something to a pin. And then ultimately does the create online session internal, which is this function down here below, passing the same two variables into it. It formulates the travel URL. So this is the start of the formation of the sort of HTML, or I guess I shouldn't say HTML, the address of where your server is going to be found in the internet. So it starts to formulate that string based on some information. And then if we're using the common user session subsystem version 1, that's a mouthful, then we'll execute this function. Otherwise, we'll execute version 2. This is sort of some forward thinking. We're using version 1. And this is how we tie to the Epic Online services. Now, it's important to differentiate that the session is not the server. The session is sort of some metadata or a pointer that gets placed out on the internet, in this case in Epic Online services, so players can find your server. So it's important to differentiate that the session and your actual server are two different things. Think of it as a pointer to your server. So you're creating a new entry in Epic's table structure, and you're telling Epic that you have a game up and running. Technically, at this point, you don't actually have the game up and running, but you will very soon. So that's the start of creating the session. From there, it sort of continues its logic down to the actual session create request. And so this line of code here, after going through and setting some values in the initialization parameters, is where you actually create the session on Epic Online services. And you can see from the comment here that it's asynchronous and it's going to wait for a callback. So the code doesn't sit here and wait. When you see things like we're running things asynchronously or we're dealing with a callback, it's because you don't want to block the code while you send a request to a remote server, wait for the remote server to respond. You don't want to do that in a sort of synchronous blocking mode. You want to push that request out there and keep going. So we'll get a callback from that once the session has been set up and run. In the meantime, we create our own callback session on create session to tell the rest of the code that, hey, we've reached this far in the process. Go ahead and trigger any processing that you might need to trigger off of on session create. Once the callback, so this is the callback routine. Sorry, this is the on create session complete. So this means that the Epic Online Services sent us back a message saying, hey, your session has been registered. Well, in theory, it's been registered. Basically, if it's successful. Now, if you're scrolling through the code, be careful here because this is actually commented out. So this block of code, if false, will never equal true. So therefore, this will never occur. but it's kind of a weird way to comment out a block of code. This is a little bit about that split screen discussion that I was talking about. We just basically end up finishing our session creation with passing our successful criteria. So as this callback is called, we trigger finish session creation. And in finish session creation, if we were successful, then we finally actually spin up the server. So in the lines of codes between requesting the session being created, the callback to our code, the triggering of the on session created complete, then we initiate the launch of the server. So this particular line, the server travel, is what will instantiate the new level and start the process of moving your player into that level. So all of that stuff that's occurring about creating a session, getting it out there on Epic Online services, all of that happens. And then at this point, you start to see things happening from a moving to a new map perspective, because we've done a server travel to the particular URL that was formulated through the bulk of the code. What's the IP address? What map am I loading, etc. So from there, that's what initiates sort of the next part of the startup logic, which is, okay, how do we get from starting up a new server copy to a fully loaded world? And for that, we're going to look at the documentation again, and look at kind of the game flow. Now, it's important to know, because timing will get you as you debug certain things, that if you're hitting a Pi instance, you're following the orange path on the screen. If you're running a compiled and executed version of the code, you're following the red path. There's some small nuances in the sequence of when some of those events are occurring. There's some points where you can only do stuff for Pi that's different. But basically, they both eventually land at the begin play of the world, right? And so that is where our server travel sort of picks up, right? We did a server travel, and we launched the UWorld begin play. That initiates the game mode, who is now fundamentally in charge of logistics for the rest of the startup sequence. The game mode, if you remember from the beginning, comes from either the level, if it override it, or the default, if it did not. So this is what kicks off Lyra game mode. Lyra game mode goes through its startup sequencing. It eventually hits a point where it's ready to start match. And once it hits start match, it spawns all the actors to begin the game. And it's an interesting and important note to know that while the game mode spawns all the actors into the world, there's some nuances to how those actors get started, and you cannot count on the sequence of how actors are spawned in, how they hit their begin play. It can be quite random in some of those things, which is why in a lot of videos you'll see people do short delay nodes to try to allow things to finish their startup sequence, which is generally a bad practice. There should be a better way to control when you want things to initiate. But if you're getting into timing issues, you're likely getting into timing issues because you're counting on a certain sequence of actors being loaded, and the engine's loading them in a different sequence. And so that can cause null check problems and other issues, particularly around the begin play event. All right, so the actors are being spawned into the world. And as I said, there are a number of paths. All right, so the yellow path is basically in the editor. Now, in the editor, it does a duplication. So the actors are duplicated from your open level into your new running instance. And so that's a very different path than if you were running the game from startup. If you're running from startup, you'll basically trigger this load map which will fetch all the actors from the map, load each one, call post load, initiate those actors for play, start them, pre-initialize any components, initialize components, post-initialize components, and then begin play. So objects that are in your map are following this blue path, as well as the PyEditor ones that get injected here. So they don't actually go back and load off this because they're already loaded in memory. And when you run through these and you get to the begin play. If your code, so let's say I've got a character, and that character's bad example. Let's say I've got a house in a level. All right, so that house will come in via the load map, and it'll run through, and it'll hit its begin play. Then in the begin play, maybe you use a spawn actor piece of code to say, okay, when this house comes into the level, I want you to spawn a light. Probably also a bad example, but you want to spawn something from your code inside the begin play of the house actor. That would trigger this light blue path where that spawned actor is then added into the map. We do the post actor created, we execute our construct, right? We do our post construct, we pre-initialize our components, and we do the exact same things that we did over here, and then we eventually get to our begin play. So because those paths are different, you can have scenarios where the timing of these is unknown. And so you shouldn't count on sequence, and you should always check things when you're running. The other important aspect, which is particularly important in Lyra, is that the components, which Lyra heavily relies upon components, their begin plays is inconsistent with the actor as well. And if you think about the logic of a game experience or the plugin game features, many of them are adding components. Well, if they're adding a component to an actor, that means the actor is already in the world and they're adding their components to it. So if you read this comment that I put here, is most times, right, the components begin play will follow the actor's begin play. Or they'll trigger when that component is added to an already existing actor. So there could be quite a gap between the actor's begin play and then the corresponding component's begin play if that component is being introduced into the actor through the game experience of Lyra. So there can be a gap. The begin play normally happens after the post-initialized components, but again, it can be delayed. So if I initialize 4 or 5 components, and this happens to be an actor that needs to replicate from server to client, there can be a noticeable delay between when the components are initialized and when the when the components are initialized and when the components begin play are triggered. So it's important to know that because Lyra uses components heavily, that you got to be careful of the timing of when that component is added to an actor, or you'll run into some timing issues. So at this point, we've run through, we've loaded our map, we've spawned in any actors that we need, our components get initialized, our components get their begin play, and we're off and running, and the level is loaded. The game mode then determines that everything is started up properly, and it will launch or broadcast that the game is starting. So that's kind of the flow of how we get through that code. I guess the last thing to talk about really is, so what happens differently if I'm joining a match as opposed to hosting a match? So all of this flow so far has been about hosting the match. If you think about it, and we'll do an abbreviated path through the join session. If you follow the join button, hit the common subsystem join session, you're basically going to follow a lot of similarities to the host, in that you're first going to go look for a session. You're going to do the same sort of logic where I ask to join a session. We do some checks. We then call the join session internal instead of host session internal. That in turn calls the Online Subsystem version 1 version of the internal. Then we get the subsystem and we request to join the session, right? We haven't joined the map. We're joining the session on the Online Subsystem, which in our case is the Epic Online Subsystem. So we make a request to join that subsystem, and we then basically finish that. And once we finish joining the session, assuming the Online Subsystem said, yes, you can join that session, we then do this internal travel to session, which inside of its code eventually calls the player controller to do a client travel. And at that point is when we actually move from the menu into an already existing server. So we will execute and follow the spawned actor path. So our player controller gets spawned, our player character gets spawned, the map had already been loaded, so we're now following the path where we talked about earlier, where the actors are being spawned into the world. And as expected, this is also not a seamless travel event. So when the client travels, when you join a map, you're doing a travel absolute, which is one of the travel types. And if you notice that the signature at the top says there's a boolean that says be seamless, you'd have to set that to true to be seamless. And if you set that to true, you can't travel absolute. There's a special travel path that you need to follow. So the net of it is either both the host and the join will do a non-seamless travel, which means you can't carry forward anything from the lobby map into the actual game session. So in summary, the game instance is first. That's the first thing that initiates, and you can largely think of it as your PC or your local world. Then the level, which is sometimes referred to as a world or a map, those are all the same, triggers which actors it needs to be loaded, the game mode, the player state, the controller. Lyra then injects any of the game experience logic. We've talked a little bit about seamless versus non-seamless travel and how non-seamless is the default travel method for Lyra, and I think 90% of games in general. We talked the difference between the session, which is the metadata that is on the Online Subsystem, of which case we're using the Epic Online Subsystem. It would be no different if you're doing Steam or others. It's the session that is on that platform versus your level or map, which is your server that you're going to spin up once you get to your server travel or your client travel node. We walk through the host versus join game, and then we walk through the actor initiation pass and any timing issues that you might have. So hopefully that gives you a bit better understanding of how the level starts up. What are some of the things you need to think about from a startup perspective, be it non-seamless travel and the fact that actors are destroyed and recreated, as well as any timing issues that might manifest as you start up a level or a map, particularly around the begin play events. All right, thanks for watching.